Hey darling, so we're going to do the second part of naming ionic compounds, and these are ternary compounds. So before, binary compounds were with two different elements. Ternary are with three or more different elements, or more than two elements in there. You'll definitely need your reference table, so make sure you grab that as well. And we're going to talk about what ternary ionic compounds are, naming them with metals that form one ion and metals that form more than one ion. So with ternary ionic compounds, we're actually to use table E, those polyatomic ions, the ones I had you memorize, in order to help you name these compounds. So pretty much what we end up doing is having maybe one or even two of these ions together. Now don't forget, ionic compounds are cations and anions. So let's go through and show you the cations, which are just these first three. The rest are going to be anions. So those cations come first, then the anions. So if an anion is from the periodic table, we just change the name to IDE, but we never, ever, ever change the name of any of these ions that are found on table E. Don't ever change them, kiddos. And pretty much you'll use parentheses if we have more than one of those polyatomic ions. So we'll go through this. The steps, we're going to assign their charges of, if we're given a compound, we're going to assign the charges. You're going to crisscross the charges, reduce the subscripts, put parentheses around polyatomic ions if there's more than one of them. And to name them, we have to name the cation first. If it's an element, just a metal with one charge, name it as is. If it's a metal that has more than one charge, just add the Roman numeral. If it's one of the polyatomic ions, name it as is. So if your cation's one of those first three, so hydronium, mercury 1, or ammonium, don't ever change the name for those. Okay, just keep them as is. For the anion, if it's an element from the periodic table that's of course a nonmetal, we'll change the ending to IDE. If it's a polyatomic ion from table E, like any of those pretty much besides those first three, we're going to keep the name as is, so we're not going to change that name at all. So let's take a look at one of those first ones. We have ammonium and oxygen. So ammonium, if we take a look on table E, it's NH4 plus 1. And then we know oxygen, straight from the periodic table, that's -2. So we're going to crisscross those crisscross the numbers, excuse me. So a 2 goes down there, a 1 goes down there. So when we have this, we have essentially two NH4s. Now, I can't do NH4 2. That's not correct. And I also can't change just the H to an 8. That's not right. What I'm saying here is I have two NH4s, and I have to put them together. So what I'm going to do is actually put those all in parentheses. So let me erase this part. And I have my NH4 in parentheses. Outside of the parentheses is going to be a 2. And then for the oxygen, just a 1 comes down, so that's it. So this is your compound, NH4, 2, O. And then we have the name, it's ammonium, because we have not changed the name from table E. And then since O is from the periodic table, it's a nonmetal from the periodic table, we change it to ide. So this compound is ammonium oxide. The next one we have here is magnesium and phosphate. Magnesium, straight from the periodic table, it's group 2, it's +2. Phosphate's PO4 -3. So we're going to move those numbers down off to the other ones. So now I have Mg3. Now, since I have two PO4s, I again have to put the PO4 in parentheses and put a 2 outside of it. So that's your Mg3PO4. And, let's see, magnesium, it only has one charge, so we don't need any parentheses, so it's magnesium. And then the phosphate is our ion. We don't change the name because it comes from table E. So here we have magnesium phosphate. So we have a few more compounds here. We have hydrogen peroxide. So hydrogen, you know it's from the periodic table. It's going to be H plus 1. Peroxide. Peroxide's from table E. It's O2 -2. So we will crisscross those numbers down there. One down there, one down there, or 2 down there, excuse me. So I have H2. Now since there's only one O2, I'm just going to make it like this. So H2O2. And that's hydrogen peroxide. The next thing I have here is copper 2 hydroxide. So it tells me what the charge of that copper is. So it's Cu plus 2. Hydroxide's from table E, so it's OH -1. Crisscross the numbers, so I end up with Cu, and then in parentheses, I will put that OH2 around. Right? So again, many times I've seen so many kids do this. It's like Cu, OH, and then the 2. Well, that 2 show me I only have 2 hydrogens. Instead, I need to have 2 hydroxide, so I have to have the parentheses around there. So that is the formula. Ammonium chlorate's the next one. So NH4 plus, and here we have chlorate. Many people want to put just the Cl minus. That would end in IDE, so that would be named chloride. That's an E there. This is chlorate. Chlorate is from table E at ClO3 minus 1. Crisscross them, so I have NH4, which is a polyatomic ion, and chlorate, which is also a polyatomic ion. There's only one of each, so I don't need to put parentheses around either one of them. So now we're given the formulas, and now we need to figure out what the names are. So I have CuNO3. Remember, Cu is copper. It can be +1 or +2, so I have Cu plus 1, Cu plus 2. I'm going to write both of them down just to see which version of copper I'm going to be using. NO3 is -1, so crisscross them. So this one becomes CuNO3, this one becomes Cu, and then in parentheses, NO3, 2. So this one was the first one that we had, or the one that matches up with the problem. So this one we will name as copper. It's Roman numeral 1 because it's the +1 version, and the NO3 is nitrate, so copper 1 nitrate. Alright, so that is your answer. The next one is LiOH. Now, you know O and H are individual elements, but together they make one of the polyatomic ions. So we have Li plus 1, OH is -1. Crisscross, and they still end up giving you LiOH, and that's good. So Li is lithium. Lithium is a group 1. It does not change its name at all, and you don't need Roman numerals because it only has one possible charge. So here we have lithium, and then that OH is hydroxide. So it's lithium hydroxide. The next one, we have Fe3PO42, so we have Fe plus 2, Fe plus 3 from the periodic table. PO4 is -3. So let's go ahead and crisscross them. So for this first one, we have Fe3, and then the PO4 is in parentheses. And then the second one, we have Fe3, PO4, 3. Those cancel, so that ends up being FePO4. So this first one was the one that we needed. That was, by the way, 2. Just kidding. Sorry about that, darlings. A 2 comes down there from the +2 charge. So let's name this one iron. It's Roman numeral 2 because it's the +2 version, and then the PO4 is phosphate. And we can squeeze that in, hopefully. Okay, so it's iron 2 phosphate. Next one, we have PbCO32. So Pb can be a +2 version, a +4 version, according to New York State. Now don't forget that there are other options that can be out there. CO3 is -2. So when we crisscross it, this one ends up being PbCO3 because, I'll show you actually here, 2, 2. The 2's cancel, so that's PbCO3. The second one, we have Pb2, and then CO3, 4, because that 4 comes down there. These can reduce down to 1 to 2 ratio, so this ends up being PbCO3, 2. This is the version that we wanted. This is the one that matches up with the actual formula. So we want the +2 charge. So I will clear out some space here. This compound ends up being lead, 4, because we use the +4 version, carbonate. We don't change it to carbonide because it's straight from table E. Alright, to summarize, if you have more than one polyatomic ion, make sure that you use your parentheses, and then use the same rules for the metals as you did before. If there's only one possible metal, or one possible ion, don't use the Roman numerals. But if it has more than one possible ion, use the Roman numerals for your charges. Don't forget your polyatomic ions. Don't try to change whatever that ion is. You can add parentheses and add subscripts after it, but don't dare try to change it from like a PO3 or PO4 to a PO or something like that. That's just silly and bad chemistry, kiddos. We will practice this a lot, so don't worry. Have a great day.